Here's another indefinite integral that we want to try to figure out. And as always, look at this and think if you know any formulas for this. And it seems like maybe one of the inverse trig results would be appropriate here, but we don't have an expression under the root that would give us an inverse sign. We would need something minus x squared, and we don't really have that going on. We have a sum there. So it doesn't really seem like that's going to work. Try to maybe do a u substitution. If you try to let u equal x squared plus 9, what's du dx going to be? Well, du dx is going to be 2x, and you don't have any other x's to cancel with what you're going to pick up here. So it doesn't really seem like that's going to be an option, so let's kind of backtrack from that. You do have a root. You do have a root in this denominator that involves a sum of squares underneath it. And what you might be able to do is you might be able to do a trigonometric substitution in order to get rid of the root and eventually allow you to find an antiderivative. So you probably have seen that when you have a root of this form, x squared plus a squared, a substitution that will successfully rationalize that expression for you or successfully get rid of the root is if you let x equal a tangent of theta. And so for our purposes, if this is a squared, a would be 3, and what we want to try to do is we want to try to let x equal 3 tangent of theta. So if we let x equal 3 tangent of theta, what ends up happening? Well, the integral is definitely going to transform. We don't want our variable of integration to be x anymore. We want it to be theta. So we're going to have to figure out what to replace dx with. So we can take the derivative of x with respect to the variable theta. And the derivative of tangent is going to be secant squared. And so we would have this times d theta as what dx equals. Right? So dx is going to be 3 secant squared of theta d theta. So my integral would then have 3 secant squared theta d theta replacing the dx. I also would want to figure out what the root simplifies to. So if I take this root and make this substitution, what ends up happening? So I'm going to be putting 3 tangent of theta in place of my x. That's going to have to then be squared, and then I'm going to have to add 9 to that. So here's what the root looks like if I put 3 tangent of theta in place of the x. Now we want to do some math with this. We're going to do some algebra with this. So I'm going to square my 3, square my tangent, so that'll make my root look like this. 9 tangent squared theta plus 9. Now I do have a common factor of 9 between these two pieces. If I factor that out, I'm looking at 9 times tangent squared theta plus 1. Now that this is a product right here, I can do the square root of 9 and get 3. Now I still have a sum right here, but there's a trigonometric identity, one of the Pythagorean identities, one of the forms of the Pythagorean identity, which says that tangent squared theta plus 1 is equal to secant squared of theta. So I'm going to replace tangent squared of theta plus 1 with secant squared of theta. Now that that's a single term and is a perfect square, we can do that root, and the root simplifies to this. So now we're ready to go ahead and replace the root with 3 secant of theta. So we're looking at 1 over 3 secant of theta. We can do a little bit of simplification with the integrand at this point. The 3's are going to cancel. We have a factor of secant in the denominator. We have 2 factors of secant in the numerator. So one of those factors from the numerator will cancel with what's in the denominator, and then our integral is going to transform into this. This is now an integral that you can look up in most integration tables. Calculus textbooks are going to have this listed in integration tables. There is a way to derive this. I'm not going to really focus on that within this video here. It involves basically multiplying by a weird form of the number 1 and then using a u substitution. But the antiderivative of secant of theta is natural log of the absolute value of tangent of theta plus secant of theta plus a constant c, since this is an antiderivative. And then the last thing to do here would be to make sure that your result doesn't depend on theta but depends on the original variable x. So at this point, we go back to this statement right here, x is equal to 3 tangent of theta. That actually allows us to draw a little triangle. Just going to take some space down at the bottom of the page here to do that. If I draw myself a right triangle, and the variable theta is right there, the angle theta is right there, this is saying x equals 3 tangent of theta. Well, that would mean that x over 3 has to equal tangent of theta, and then from SOHCAHTOA, you know that tangent is opposite over adjacent. So opposite of the angle theta, we would have x, right, opposite over adjacent. Adjacent to the angle theta, we'd have 3, and then if you use Pythagorean theorem to solve for the hypotenuse, you're going to get 9 plus x squared, which was the original root that we started with. So now our result is going to be the natural log of the absolute value, not of tangent of theta. We want to replace tangent of theta with what tangent of theta equals. Well, that's pretty easy. Tangent of theta is x over 3. So tangent of theta is x over 3. Now the reason why the triangle is drawn here is so that we can properly replace secant of theta. Secant is the reciprocal of cosine, right? Secant is 1 over cosine, and cosine is adjacent over hypotenuse. And the reciprocal of that would tell us that secant is going to be hypotenuse over adjacent, right? The reciprocal of cosine, h in the top, a in the bottom. So the hypotenuse of our triangle is the root that we started with in our denominator, so 9 plus x squared. And then over adjacent, and adjacent we have a measure of 3 units. So we've replaced tangent of theta with what tangent of theta equals. We've replaced secant of theta with what secant of theta equals based on the triangle that we were able to draw here. Tack on your plus c at the end, and there is your antiderivative. So another trig substitution.